Hi, I'm Paul Battaglia, and this is section 5.5, multiple angles and product to sum formulas. You know, if students were to look at the text before class, they might seem a little bit overwhelmed because they're going to see all these different formulas, and they're probably going to think to themselves, do I have to know all these, or do I have to memorize all these? So one of the things I like to do to put students at ease right away is tell them I don't need them to memorize these formulas. Now, it's a personal preference, but to me it's more important that they know how to work with them and they know how to use them. Now, to that end, we're going to talk specifically about double angle and half angle formulas. And I brought Gabe and Brittany with me today. And Brittany, talk to us a little bit about a nice little trick that you like to show students with the double angle formulas.
Yeah, for the double angle formula for tangent 2x, okay. I like my students, since it's a little intimidating to them, I say it's okay to use sine 2x over cosine 2x.
Sure. Yeah. And I think what we want to stress to students is we're still trying to find an exact value. And to be honest with you, they could have even done this in a previous section with sum and difference formulas as long as they stay consistent. So for instance, if they were trying to evaluate tangent of a plus b, as long as they're doing sine of a plus b over cosine of a plus b, for them that might actually seem a little bit more doable than working with the tangent of the sum and difference formula, or in this case, the double angle formula. Gabe, tell us a little bit about how you want students to work with the half angle formula.
Okay, so the half angle formulas are worked with in a similar fashion to all the other formulas in this section.
Right.
But something special happens when you're working with them.
Okay.
So you'll have sine of u divided by 2 is equal to plus or minus the square root
of all this big expression, right?
Yeah. So we're not expecting the students to memorize that, but what they need to know is how to treat that plus or minus. It's not that sine of u divided by 2 is plus some number and minus some number.
So two answers, right?
Yeah.
Right.
That plus or minus is actually determined by which quadrant that the original angle, the u divided by 2, is in.
Could you give us a specific example?
Yeah, so for instance, let's think about maybe even cosine of 75 degrees.
Okay.
So this is something that students might not recognize from the unit circle.
Right.
So they might say, okay, well, I do know cosine of 150 degrees from the unit circle. So they might want to work with that, but then they'll get to the end and they'll say, well, do I want to choose plus or minus whatever number I might find? And that really comes down to looking back to saying, okay, I was looking for cosine of 75 degrees, which is between 0 and 90 degrees.
Correct,
So it's in the first quadrant, so I want to choose positive.
Okay.
And students might get confused and say, wait, am I looking for the quadrant that 75 degrees is in, the first quadrant, or am I looking for the quadrant which 150 degrees is in, the second quadrant? And that'll determine whether or not the answer is positive or negative.
Perfect. And I think one of the things you can do is as you're working through these with your students, try and get them to not I want to say prove, but at least look at these maybe from multiple perspectives using different formulas, seeing how the different formulas can actually give you the same answer, which I think is a good thing to do. I hope you found these tips helpful and that you find much success in section 5.5.